let's take a look at this worksheet here. Let's take a look at number 9. A particle moves along a coordinate axis in such a way that its position, let's say in feet, at time t, let's take that in minutes, is given by this position function right here. And they want us to find the velocity at a particular time of pi over 4 and the acceleration at a particular time of pi over 4. And then it says to compare these and decide whether the object is speeding up or slowing down. So before I do this problem, I want to address how we can tell if an object is speeding up or slowing down. So I hope you understand that the position function tells you where you are at different times. So maybe I'll go this way. So if you're at time t equal to 0, you might be like right here. At time t equal to 1, you might be right here. At t equal to 2, you might be right here. 3, 4, 5, 6, 7, whatever. It could move all along, whatever. So the position tells you where you are. The velocity tells you how fast you're going. So, your object could be going at a very steady speed like this. This would be positive velocity because it's going to the right. Your object could be going backwards like this. This would be a negative velocity. Okay. And acceleration is how fast the velocity is changing. So if it's moving at a very steady speed like this, then the velocity is positive, but the acceleration is 0 because the speed is not changing. If it starts off slow and then it speeds up like that, then you have positive acceleration. Okay. So what does this have to do with speeding up and slowing down? Well, speeding up is talking about a relationship between velocity and acceleration. And slowing down is also talking about the relationship between velocity and acceleration. So when an object is speeding up, that means that the v of t and a of t have the same sign. Okay. And slowing down is going to be v of t and a of t have opposite signs. So one way you can think of this is if your object is moving in a positive direction and it's also accelerating, then it's going in this positive direction, but it's going faster and faster and faster. So that would be speeding up. On the other hand, let's say your object is going in this positive direction, but the acceleration is negative. So you're still going this way, but the rate of change of your velocity is getting smaller and smaller and smaller. By definition, that should mean you're slowing down. So maybe you're going fast and then you slow down like that. Okay. So we're really comparing the signs of those two at a particular point in order to see whether it's speeding up at that point or it's slowing down at that point. Okay. If I were to draw a graph for you, let's say I drew a graph that looks something like this. This is something that's sometimes referred to as an S-curve. It's a good way to sort of visually describe maybe adoption of new technology or spread of a virus or something like that. If you look at this guy, at the beginning, the slope is pretty shallow, but it gets steeper and steeper. So on this part right here, because the velocity is getting steeper and steeper, and the slopes are all positive, they have the same sign. So on this part of the curve, the virus or the adoption is speeding up. Sometimes around the middle here, it gets close to vertical. That's when you have this really bubble like situation. Everyone's going crazy. It's like, oh, it's the hottest new thing. But then eventually over time, things start to taper off. Maybe everyone gets vaccinated, or maybe everyone already got sick, or something along those lines. So if you look, it's still increasing. But then if I look at the slopes now go from really positive to like less positive to like even less positive. So in this case, my function's still increasing. So the so the velocity is still positive, but my acceleration is negative because those slopes are getting smaller and smaller. So that would be a case where it's slowing down. Whereas the green case at the bottom, this is speeding up. Okay. So I don't know if you guys have seen these S-curves before, but I'm really interested in like crypto and stuff. So like this S-curve kind of shows up a lot. It's like adoption. Great. So now that we understand this idea and we just got to compare the two signs, why don't we answer the question? So we're going to start off with our position function S of t, which is equal to 2 minus sine t. And then we need to calculate the velocity, which is just the derivative of the position. The derivative of 2 is going to be 0. The derivative of negative sine is going to be negative cosine of t. If we want to find the acceleration is the derivative of the velocity. The negative sign stays there. The derivative of cosine is negative sine of t. So, so in the end, you're just going to get sine of t. All right. So what we need to do now is we need to calculate the velocity at time pi/4, which would be negative cosine of pi/4. So how are we going to figure that out? Well, we have really kind of three special triangles. But one of them is this triangle where we have pi/4 and pi/4 and 90. And that was the 1-to-1 to rad 2 triangle. So we're looking at this angle right here. As we know, cosine is the adjacent over the hypotenuse. So when I go to calculate what that is, that's going to equal to negative 1 over rad 2. And our units should be feet per minute. If I look at the acceleration at time pi/4, that's going to be equal to sine of pi/4. That's going to be, remember, sine was the opposite over the hypotenuse. So that's going to be equal to, when I look at this angle right here, the opposite side is 1, the hypotenuse is rad 2. So this is positive 1 over rad 2. And the units for this guy is feet per minute squared. It's because you're differentiating by time twice. So you pick up 2 units of time in the denominator. So it's like position is feet, velocity is feet per second. Position is feet, velocity is feet per minute, acceleration is feet per minute, right? Feet per minute is the unit of velocity per minute, because you look at the rate of change of the velocity with respect to time. So that's why it's feet per minute, which is feet per minute squared. Okay. So I'm going to move this guy down here. And this is our answer. So when you look at this, would you say it's speeding up or it's slowing down? What do you think? You can type your answer in the chat box or unmute yourself if you want. That's right, Luciano. Slowing down. Okay, maybe I'll highlight that part too. Any questions? All right.